Okay, so we're going to finish off the idea with solving linear equations with kind of a challenge section. So when we look at these problems, there's absolutely zero way that these problems will fit in between the space that's given to you. So you need to take them out. So please take them out. If you are doing them on this sheet of paper, you will do them incorrectly. I can guarantee it. This one's kind of a similar one to what we've been doing though. So 5 times 3 is 15. 5 times negative 2y is negative 10y plus 4y gives me 3. I've got like terms on the same side. Okay, like terms on the same side, negative 10y plus 4y, so I've got 15 minus 6y equals 3. Like terms on opposite sides, here's a 15 and a negative 3, so I subtract 15. So I have negative 6y equals negative 12, divide by negative 6, divide by negative 6, and y gives me 2. I can, of course, check that in my equation, but we have been doing that for a while, so we're going to move on. Here's a nice, decent one that follows that same logic. Oh, that's too many. It distributes only to the 4 times 1 and the negative 3. And they're x's, not y's. So I've got, again, like terms here. So I've got 4 and then negative 12 plus 7 is negative 5x equals 9. If you want to draw the river in, I'm going to start moving the 4. Negative 5x is equal to 5 divided by negative 5. And x is equal to negative 1. Here's where the challenge part starts coming in. Look at all the sets of parentheses. We even threw in a set of brackets. Okay? But it's really the same thing. If you see parentheses, do the parentheses. So I've got 3 bracket 2. Negative 4 times y is negative 4y. Negative 4 times negative 1 is plus 4. Parentheses. Now the parentheses went away because I used that distributive property. So when you use the distributive property, the parentheses go away, just like they always have. What ends up happening is that I also have a set of brackets here, but the brackets act just like parentheses, so not much else is going to happen here in terms of new information. I'm just doing that a couple times. So now I've got on the same side, I've got these two. So 6 plus 12, same side, same operations. Negative 12y plus 18 equals 6y plus 24. Now I've got variables on both sides, so opposite sides, opposite operations. So either I can add 12y or I can subtract 6y. I'm going to choose to add 12y because then my numbers stay positive. And I like positive numbers. I've got these two. I've got the option of subtracting 18 or subtracting 24. This time I'm going to subtract 24 because my goal is to get the y by itself. Okay, before my goal is to try to keep things positive. Now my goal is I don't have a choice. I have to get the y by itself. So if it comes out negative, it comes out negative. So I've got negative 6 equals 18y. Divide by 18, and y equals negative 6 divided by 18, but I can reduce that. Negative 6 goes into both of them, so I get 1/3 with a negative, negative 1/3. And the last one here really kind of does the same idea, so I've got a parentheses inside here, so I want to do that one first. Negative 2 times negative 3 is positive 6, plus 1 equals 2x minus 3. Another option for you, some people say, well, I've got some like terms inside the parentheses. Okay, go ahead and do that. So I've got 1x minus 4x is negative 3x plus 6. And that's an okay step. That's different than what we did on the last problem. But it's still okay. We're combining like terms. We did the same operation because they were on the same side. Now I still have this distributive property to do, but I'm only doing it to 2 things instead of 3, but I'm going to come out with the same answer. If I multiply right, negative 4 times negative 3 is positive 12x, and then negative 4 times 6 times 4 is 24, with a negative 2x minus 3. Same side like terms, 12x minus 23 equals 2x minus 3. Want to move the x's, I have the choice of subtracting 12x or subtracting 2x. I'm going to subtract 2, so I get 10x minus 23 equals negative 3. Now I need to get the x by itself. I've got a nice friendly equation here. Add 23 to both sides. 10x equals 20. Divide by 10. And x by itself is 2. Okay, so we're finishing off this solving linear equations idea with a little bit more challenging problems that have a few more steps in them. But ultimately, it's really the same. We've done the distributive property. We've done variables on the same side. We've done variables on opposite sides. We've solved these nice friendly equations. We've done all of this stuff. Okay? Think back to when you first started solving equations, even in this class, but even all the way back to Algebra 1, I would hope that you looked at a problem like this and you were a little bit afraid of it. But now that you've worked on it in Algebra 1 and now in Algebra 2 again, that you look at this problem and you're like, oh, I can do that. There's no issues with the work that needs to happen in solving this type of a problem. Okay, good luck when you're taking your test on linear equations. This is a good basis for us to continue moving on to do some extra fun quadratics.